Hello everyone. So in this video, we are going to discuss trigonometry and subtopic are compound angles. So in the part 1 trigonometry, I gave this homework questions. So let's see these homework questions first. Then we will proceed with the subtopic compound angles. So if you look at the question number 1, so what I gave in the question number 1 is find tan 2 pi by 3. Tan 2 pi by 3, tan 2 pi by 3. So if you don't know what is 2 pi by 3, just substitute the pi as 180 degrees. So pi value as 180 degrees, pi radians is equal to 180 degrees. So if I substitute tan 2 into 180 degrees divided by 3. So 3 ones are 3 6 are 0. So tan 120 degrees value we have to find out. So in the part 1 I told very clearly to the nearest quadrant angle that if possible try to convert into even angles. So that is tan 180 minus 60 is nothing but 120. So this is belongs to Q3. 180 minus theta is belongs to Q2. Sorry, 180 minus 60 is belongs to Q2. In Q2, tan is negative. So minus tan 60 degrees. So tan 60 is root 3. So we'll get minus root 3 as the answer. So this is the first question in that. So next what they are given in the same question is find the cos 315 degrees. So cos 315 degrees, how can we find? So for a change, I will try to take it in odd angles. So like cos 270 degrees plus 45 degrees. So if I'll assume this as a theta, so it will become 270 plus theta. It will become 270 plus theta. So 270 plus theta is in fourth quadrant. So Q4 cos is positive only. Cos is positive only. So, but it is odd angle, right? So we can change it like sine. So plus sine theta. Theta means 45 degrees. So which is 1 by root 2. So therefore cos 315 degrees is 1 by root 2. So next one, what they're given next one? Secant 210 degrees. Secant 210 degrees. So secant 210, we can write like secant 180 degrees plus 30 degrees. So secant 180 plus 30. If I assume this as the theta, 180 plus theta is belongs to quadrant 3. In quadrant 3, secant is negative. So we'll get negative answer. And 180 is even angle. So since it is even angle, there is no change in the trigonometric ratio. So we'll get minus secant 30 degrees. So cos 30 is root 3 by 2. So secant 30 is 2 by root 3. So we'll get minus 2 by root 3 is the answer. So this is the first question solution. How can we solve? Let's see question number 2. Find the value of sine square pi by 4, sine square 3 pi by 4, sine square 5 pi by 4, sine square 7 pi by 4. So if you look at this one, 3 pi by 4, like that we have. So what they are given is question number 2, sine square pi by 4 plus sine square 3 pi by 4 plus sine square 5 pi by 4 plus sine square 7 pi by 4. So pi by 4 in the sense, pi by 4 in the sense 180 by 4, which is 45 degrees. So 3 pi by 4 means 3 into 45, which is 135 degrees. Next to 5 pi by 4 means 5 into 45. So 90 plus 90, 180, 225 degrees. Next 7 pi by 4 is 7 into 45 degrees. So 270 plus 45, 315 degrees. So this 45 degrees is belongs to Q1, this belongs to Q2, this belongs to Q3, and this belongs to Q4. Q4. So we know that sine is positive in quadrant 1 and quadrant 2, that is Q1 and Q2. And in Q3 and Q4, so it is negative. So, and 45, all the multiples of 45, it will be 1 by root 2. So, sine 45 is 1 by root 2. We have whole square plus 3 by 4 means 3 pi by 4, 135 degrees. That is also 1 by root 2 whole square plus 225 lies in the third quadrant. So, that's why it will become minus 1 by root 2 whole square plus 315 is in fourth quadrant, so we'll get minus 1 by root 2 whole square. So here we'll get this one as 1 by 2 plus 1 by 2. So this minus will become plus since we have the even square. So 1 by 2 plus 1 by 2. So this answer is 2. So this is the way how we will solve the second question. So what they are given the third question, find cot A plus tan 180 plus A, tan 90 plus A, tan 360 minus A. So what is the question is? Question is cot A plus tan 180 plus A plus tan 90 plus A, tan 90 plus A plus tan 360 minus A. So this is the question. So how can we solve this one? So if you look at the solution, cot A, there is no change. It will be like that only. 180 plus A belongs to quadrant 3. So tan is positive only. And 180 is the even angle. So there is no change in the trigonometric ratio. So we'll get tan A as usual. Plus here 90 plus A is the Q2. In Q2, tan is negative. So minus we will get. And this is the odd angle. So tan will be changed as cot. So we'll get cot A minus cot A. Plus 360 minus A is belongs to quadrant 4. So this is even angle. There is no change in tan. So in Q4, quadrant 4, tan is negative. So we'll get minus tan A. So if we'll simplify this one, cot A plus tan A minus cot A minus tan A. So plus cot A minus cot A plus tan A minus tan. So answer for this one is 0. So let's see question number 4. If secant theta plus tan theta is equal to 1 by 5, find the sin theta. So what is the question number 4 is, they are given, let's read the question. Let's read the question full, then you'll understand clearly. If secant theta plus tan theta is equal to 1 by 5, then find the value of sin theta. So this is the question. So let's see solution for this one. What they're given is secant theta plus tan theta is equal to 1 by 5. Let it be equation 1. So we need to find out the sin theta value. So how can we find this one is, we know one relation between secant and tan. That is the identity secant square theta minus tan square theta is equal to 1. Secant square theta minus tan square theta is equal to 1. So in this, if I assume secant theta as some A and tan theta as some B, so this formula become like A square minus B square is equal to 1. So which can be written as, this is one formula like a plus b into a minus b is equal to 1. A plus b into a minus b is equal to 1. So according to this we can write secant theta plus tan theta into secant theta minus tan theta is equal to 1. So we know the value of secant theta plus tan theta from equation 1, that is 1 by 5. 1 by 5 into secant theta minus tan theta is equal to 1. So this is equal to this is equal to secant theta minus tan theta is equal to 5 we will get. That is the equation 2. So let's we solve 1 and 2. So 1 plus 2 if we do. So secant theta plus tan theta, we know 1 by 5. Secant theta minus tan theta, we got 5. So if you'll subtract, if you'll add these two, so plus tan theta minus tan theta gets cancelled. So 2 secant theta is equal to 1 by 5 plus 5, which is 26 by 5. So 2 ones are 2 13s are. So we will get secant theta as 13 by 5. So from here, I'll get the cos theta value as 5 by 13. So, but we need to find the sin theta. So we have a relation between sin and cos, that is sin square theta plus cos square theta is equal to 1. So from where I did the sin theta is under root of 1 minus cos square theta. Otherwise, we can go with the right angle triangle also. So there is a different ways. If I'll go through right angle triangle, if I take this is the theta, this is adjacent side, this is the hypotenuse. So according to Pythagoras theorem, we will get this is 12. So directly we get sin theta is equal to 12 by 5. 12 by 5. So plus or minus 12 by 5, because cos is positive in Q1 and Q4. So when we'll take this one is in Q1, this is plus. When it will take in Q4, this is minus. So you'll get plus or minus 12 by 5. So here also sin theta is plus or minus 12 by 5. So we will get plus or minus root over 1 minus 5 by 13. So 1 minus, so this is not 5, hypotenuse, right? So this is 13. This is 13. So substitute here cos theta value, that is 5 by 13 whole square. So we'll get plus or minus root over 1 minus 25 by 169, which is plus or minus root over 169 minus 25 by 169, which is equal to plus or minus root over 144 by 169. So therefore, sin theta is equal to, we'll get plus or minus 12 by 13. So this is the way, two different ways how can we find. This is the one way by using the right angle triangle. This is the method two. By using the identity, we can find out the value of sin theta. Okay, so let's we proceed for in today's topic. So that is before going to compound angles. So we will discuss a small topic that in place of theta, it will replace minus theta. So how the trigonometric ratios acts. So for that we will take one's coordinate system so we can understand nicely. So this is y-axis and this is x-axis. So let's we take from origin. So we are taken one line like this, and to the fourth quadrant also will take. So let's we join this. So we will get like this. So yeah, so this one, And if we'll take the angle, this is theta. So in this direction, this will become minus theta. And we know this is r. So this is also r, radius of the circle. And if we'll take this is y, this will be minus y. So this is x. So let's think this is O, and this is A, this is as B. So if I'll take sine of minus theta from the triangle ACB or ABC, so sine of minus theta will be minus y by r. This is r, minus y by r. So that will be minus y by r. Y by r from the triangle OAC is sine theta. So minus sine theta we will get. So if we'll take cos of minus theta, that is x by r. So which is equal to cos theta only. So we'll take tan of minus theta. So these all are, we are taking from here. We are taking from here. And later, while writing this, we are comparing with this triangle. So tan of minus theta will become minus y by x, which is minus tan theta. So like this, we'll get all the trigonometric ratios. So what we'll get? What we'll get? So we'll finalize here. Sin of minus theta will be minus sin theta. Cos of minus theta will be plus cos theta only. Tan of minus theta will be minus tan theta. Cot of minus theta will be minus cot theta only. Secant minus theta will be plus secant theta. Cosecant minus theta is minus cosecant theta. So here only for cos and secant output you will get as the positive. So remaining all are negative. So this is the first topic in this today's video. So let's see one small problem based on this. Tan of minus 135 degrees. Tan of minus 135 degrees. So how can we solve this tan of minus 135 degrees? First of all, you have to apply here to remove this minus from here. That we know that tan of minus theta will be minus tan theta. So according to this, this I'll write like minus tan 135 degrees. So next, minus tan 135 can be written as 180 minus 45. So this is belongs to quadrant 2, 180 minus theta. So where tan is negative. So already we have negative outside. So negative into negative, it will become positive. Tan 45 degrees. So this ratio won't change since it is even angle. So tan 45 is 1. So therefore, tan of minus 135 degrees, we are getting the 1. So this is the way how we will find out the negative values. For negative values. So let's see today's topic, compound angles. Let's see compound angles. So compound angles. What is meant by compound angles? So two or more angles, some are difference is called compound. So the algebraic sum, how can we define mathematically? The algebraic sum of the algebraic sum of two or more angles. The algebraic sum of two or more angles is called a compound angle. Two or more angles is called a compound angle. Compound angle. A compound angle. The algebraic sum of two or more angles is called compound angle. So example. So cos A plus B, like a plus B simply A plus B plus C, A plus B plus minus C, which can be written as A plus B minus C, or B plus C, or B minus C, A minus C. So these are all called compound angles. That is nothing but sum of two or more angles, algebraic sum of two or more angles. So this is called compound angles. So here in this, we have different formula for compound angles. In that, first one is sine A plus B. Sine A plus B is sine A cos B, sine A cos B plus cos A sine B. So this is the first formula. Then we have sine A minus B, so which is sine A cos B minus cos A sine B. Next, third one, cos A plus B, cos A plus B. We have cos A cos B minus sine A sine B. Next, we have cos A plus B over it, cos A minus B. So cos A cos B plus sine A sine B. So and next we have tan A plus B. So tan A plus B we can take like tan A plus tan B divided by 1 minus tan A tan B. So next tan A minus B, tan A minus B we can write like tan A minus tan B divided by 1 plus tan A into tan B, tan A into tan B. So these are the different formulas. Even we can write for secant A plus B, secant A minus B, cosecant A plus B, cosecant, but those are the reciprocal of this one. So by taking the reciprocal formula of this one, you will get that. Otherwise, by changing it to sin and cos, you will get the compound angle. So let's see how can we prove this. So we'll see proof for only one, and remaining all will be in the same way. From the same diagram we can take. So how can we take this proof? So proof of sin A plus B is equal to sin A cos B plus cos A sin B. Let's try to prove it in a simple way. So first, let's understand the diagram. Let's understand the diagram. So here, this is the initial ray. Let's think this is the initial ray, and these are the another two rays. Another two rays we have. So this is one ray, and another ray is. So this is the one from the same vertex, from the same vertex. So let's we think this is the vertex where the angles are forming, and let's we think this is the angle A, and this is the angle B between these two. So let's we think this is the OP ray, and this is the OQ ray. This is the OQ ray, and this is the OR ray. So to prove this one, let's we construct something triangles. So first of all, so from here, I'll take one perpendicular from this to the OP. So to the OP, so this is perpendicular. Let's think it's intersecting this one at L. Okay, so from here, how can we take to this one is, so from here to here, let's take LM. So we'll draw one perpendicular here also. This is one more perpendicular from Q to P. And let's think it is intersecting at this P. Okay, and one more. So one more, draw perpendicular from R to OQ. So and we can extend this one. We can extend this one. So like this. And from here, if you will draw one perpendicular to this one, so let's think this is intersecting at yes. So this is one right angle. So if you'll observe clearly here, one right angle triangle is OLR and one right angle triangle is OPQ and one right angle triangle is OQR and one more is RSQ. So total we have four right angle triangles. So if you'll see the proof for this one, if you'll see the proof, so we need sine A plus B, right? So A plus B will come from triangle OLR. So in triangle OLR, sine A plus B, sine A plus B, I can take like RL by OR, RL by OR, RL by OR. So, but I don't know RL, right? So RL I cannot find directly. So, but see here, so from R and S, I drawn the perpendicular to the same line OP. So that means RL is parallel to SP and RL is equal to SP. So by that I can write RL like SP by OR. So what is mean by SP here? So what is mean by SP here? So SP is, we can write like SQ plus PQ divided by OR. SQ plus PQ divided by OR. So let it be 1. So let's find out here what is SQ, what is PQ. So to find out the SP and PQ, I mean SQ and PQ, PQ, first PQ, we will get from triangle OPQ. In triangle OPQ, this is opposite side. This is the hypotenuse. So sine A will be PQ by OQ. PQ by OQ. From here, PQ I can write OQ sine A. PQ I can write like OQ sine A. So this is one result. So I need SQ also, right? So SQ from where I will get? So from triangle RSQ. From triangle RSQ, we need the angle right here. So when this is A, this is 90. This is remaining 90 minus A. This is remaining 90 minus A. And this is 90. This is 90 minus A means this will be A. This will be A. So according to that, this is adjacent side. According to angle A, this is adjacent and this is the hypotenuse. So here adjacent by hypotenuse means cos A. Cos A is equal to SQ by RQ. So from here, SQ can be written as RQ cos A. So we got cos SQ is equal to RQ cos A. So okay, let's finalize here only. Let's finalize here. So these are the two results. So what we got, what we required in the equation 1. So this is one result. This is one result. And this is another result. Let's substitute these two results in the equation 1. So what we will get? So what we will get is sine A plus B. Sine A plus B. Sine A plus B is equal to SQ. SQ means RQ cos A plus PQ is OQ sin A divided by OR. So this we can write like RQ by OR into cos A plus OQ by OR into sin A. So if you look at the triangle OQR, so in triangle OQR, what is mean by RQ by OR is sin B and OQ by OR is cos B. So let's substitute this in the this result. So we will get sin A plus B, sin A plus B is equal to RQ by OR is sin B. So sin B into cos A plus OQ by OR is cos B. So cos B into sin B. So therefore, sin A plus B is equal to sin A cos B plus cos A sin B. So this is the way how we will get the sin A plus B formula in compound angles. So remaining all directly by replacing the B as minus B. So replace B by minus B. So you will get sin A minus B. Sin A minus B. So that is sin A cos of minus B plus cos A sin of minus B. So that is cos of minus theta is plus cos theta only, and sin of minus B will be sin of minus theta will be minus sin theta. So according to this, you will get sin A cos B minus cos A sin B. So this is sin of A minus B, sin of A minus B formula. So if you want cos A plus B and cos A minus B, so cos A plus B will become what here? OL by OR. OL by OR. So how can we get the OL? This and the OL directly will not get. So that's why OL can be written as OP minus LP. OP minus LP. So cos A plus B, how can we find from here is cos A plus B is equal to OL by OR from triangle OLR. From triangle OLR. So OL directly we cannot find. That's why we can write it as OP minus LP by OR. So OP you will get again from triangle OPQ, and that LP is equal to RS. So LP is equal to RS by OR. So here OP you will get from triangle OPQ, and RS you will get from triangle RSQ. So again do it similarly. You will get the proof for cos A plus B also. So how can we get the tan A plus B here? So how can we get tan A plus B? So tan A plus B, so we can take like sin A plus B by cos A plus B. So what is the sin A plus B formula? Sin A cos B plus cos A sin B. So whole divided by cos A plus B is cos A into cos B minus sin A into sin B. So divide numerator and denominator with cos A into cos B. So if you divide that, so it will become sin A cos B by cos A cos B plus cos A sin B by cos A cos B divided by cos A cos B by cos A cos B minus sin A sin B by cos A cos B. So here, if you look at clearly, cos B cancel, cos A cancel, here both are cancelled. So what we will get answer for this one is sin A by cos A plus sin B by cos B divided by 1 minus sin A by cos A into sin B by cos B. Sin B by cos B. So we can get tan A plus B as sin A by cos A is tan A plus sin B by cos B is tan B divided by 1 minus tan A into tan B. So this is the way how we will get the tan A plus B formula. So A minus B, if you want, replace B by minus b. Otherwise, directly you can proceed the same way. Like tan a minus b, you can take like sin a minus b by cos a minus b. So this is the way how we will get this formula. So compound angles formula with proofs we saw. So let's see. So how to solve the questions based on this. So first question based on this. The question is the value of cos 45 minus a into cos 45 minus b minus sin 45 minus a sin 45 minus b. So this is what we have to find out the question. It's a solution. Solution is, if you'll observe clearly, if I'll assume this as some theta 1 and this as some theta 2, so this is also will become the theta 1 and the theta 2. So if you'll observe clearly, this will be converted into cos theta 1, cos theta 2 minus sin theta 1, sin theta 2. So what we learned the formula just now for this one, cos of theta 1 plus theta 2, cos of theta 1 plus theta 2. So where the theta 1 is 45 minus a and theta 2 is 45 minus b. So let's substitute that directly here. So we will get cos of 45 minus a plus cos of b theta 1 is 45 minus b. So that means you'll get cos of 45 plus 45, 90 minus a minus b. So this one we can write cos of 90 minus a plus b bar bracket. That means this a plus b completely outside we have minus. So let us assume this as the theta. So cos 90 minus theta, we will get, this is first quadrant only. So this is odd angle. This is odd angle. So we'll get sin theta. So we'll get sin of theta means here a plus b. Sin of a plus b. So this is the way how we will use this compound angle formula. So next question. Next question. So what is the next question is? Question number 2. Next question. The value of sin n plus 1 into a into sin n plus 2 into a plus cos n plus 1 into a cos n plus 2 into a equal to. So let's me rewrite this question according to our formula. Cos n plus 1 into a into cos n plus 2 into a plus sin n plus 1 into a sin n plus 2 into a. So this, it is, if you assume this as the a and this as the b, so this will become a and this will become b. So then we'll get here cos a cos b plus sin a sin b. So whose formula is cos a minus b, cos a minus b. So according to this formula, so what we'll get here is cos of a means n plus 1 into a minus and b is n plus 2 into a, n plus 2 into a. So this is equal to cos of na plus a minus na minus 2a. So this is what we'll get, plus na minus na cancel, a minus 2a is minus a minus a, cos of minus theta is plus cos theta only. So we'll get cos A as the answer. So hope you understand this question. So next what we can take, one more question is question number 3. Question number 3. Value of sin theta plus 120 minus sin theta minus 120 minus theta. 120 minus theta. 120 minus theta. So how can we find the value of this one? So here we need to apply we need to apply sin A plus B formula. That is sin A cos B plus cos A sin B plus cos A sin B. Here we need to apply sin A minus B formula, which is sin A cos B minus cos A sin B. So let's apply this formula for this particular terms. First term is no change. For the second term, let's apply sin A plus B. That is sin A means sin theta cos B 120 degrees plus cos theta sin 120 degrees. Since we have minus next, keep the bracket. So sin 120 cos theta minus cos 120 sin theta. Now sin theta plus, open the bracket. So since you have plus outside, there is no change in the sign. Sin theta cos 120, we can write like 180 minus 60 plus cos theta into sin 180 minus 60. So here we have minus. So if you open the bracket, the first term will become minus sin 180 minus 60 into cos theta. So minus into minus plus cos 180 minus 60 into sin theta. So this is equal to sin theta plus sin theta into, this is belongs to second quadrant, 180 minus theta. So it will become minus cos 60 plus cos theta into, so sin 180 minus theta is belongs to second quadrant, so it is positive only. So you'll get sin 60 minus, here also sin 60 only, plus only, into cos theta. So here it will be minus cos 60 into sin theta. So if you'll simplify this one, sin theta plus into minus cos 60 is 1 by 2. So we'll get 1 by 2 sin theta. Here root 3 by 2 cos theta. Here we'll get minus root 3 by 2 cos theta again. So here minus 1 by 2 sin theta. So here what we'll get? So what we'll get here? So this and this cancel. So this and this cancel. So if you look at the remaining, this is sin theta. This is minus half sin theta minus half sin theta means sin theta minus sin theta. So sin theta minus sin theta, which is 0. So this is the way how can we find this problem. So next, so one more problem. Let's